Hey everybody, welcome back to a proof a day. Today we are going to be showing that the eigenvalues of an n by n matrix are the roots of the characteristic polynomial. Now the characteristic polynomial I will denote by p of lambda, which is equal to the determinant of a minus lambda I. Alright, so to start this proof we're going to assume that lambda is an eigenvalue of some matrix A. If so, that means that we then have the equation A v is equal to lambda v, where here v is an eigenvector of A. So what we can do here is we can just move the lambda v to the other side, which then gives us, and pull out the v, we get A minus lambda I times v is equal to the 0 vector. So now when we're doing this we want to stay away from trivial solutions. In other words, we really do not want our v to be equal to the 0 vector. That's kind of redundant. It's like, of course that's going to work. So we're going to look for when that doesn't happen. So the key here into solving this is what's going on over here with A minus lambda I. Well, the trick is to notice whether or not it's invertible or not. So let's assume that it is invertible and see what happens. Well, if it is invertible, then I can multiply its inverse on both sides. So that would give me A minus lambda I inverse by A minus lambda I, and then that times V is equal to A minus lambda I times the 0 vector. Now anything times the 0 vector is just going to be 0. Likewise, any inverse times itself is going to then be 1. So if this thing is invertible, we actually get that trivial solution that we do not want. So that means if we are to get some sort of non-trivial solution for v, then we want our A minus lambda I to be non-invertible. Now, if something does not have an inverse, that means that its determinant is 0. So therefore we want the determinant of A minus lambda I to be 0. But if we recall, we define our characteristic polynomial to be that. So therefore, the characteristic polynomial is equal to 0. And as we know, if our polynomial is equal to 0, then if for any value of lambda that satisfies this equation, it's a root. Since lambda is our eigenvalue, that means that any eigenvalue of some matrix A is then a root of its characteristic polynomial. Thanks for joining us again. Hope to see you guys next time.